background about Hardware Massive. So welcome to Hardware Massive. Thank you so much for joining us tonight. So let's see. What is a hardware startup? So a hardware startup is defined as a startup that takes any physical product to market. So it doesn't have to be just restricted to electronics. It could be anything from a camera to a wooden toy or even clothing. So Hardware Massive's mission is to empower hardware startups to successfully take physical products to market through education, community, sharing of knowledge/resources, and networking. So how did they begin? So they began it as individual meetup groups, but Meetup wasn't a sufficient platform for connecting hardware startups. So connecting hardware startups after the events. So what happened was they developed the Hardware Massive platform to connect people in the hardware ecosystem, not just locally, but globally with other cities. So now Hardware Massive has become a global platform with local chapters all around the world. So we are the Taipei chapter. Okay, so we're always looking for more speakers and sponsors. So if you guys are interested for speaking or sponsoring the Taipei chapter, please let me know. So each year, Hardware Massive holds a Hardware Con. And below you can see some of the sponsors and speakers from the past Hardware Cons. So this year, HardwareCon 2017 is happening March 24th and 25th, and it's basically focused on connecting startups to major retailers. So if you're interested in attending this event, you can sign up on the Hardware Massive website, or you can let me know. Okay, so now without further ado, please join me in welcoming our speaker for tonight. Here to talk about the challenges in large-scale IoT, Mr. Alan Houng.
Yeah. All right, I got a mic. Okay. Hey guys. So I apologize beforehand. This talk is going to be very. I didn't have much time, so I kind of put together kind of a series of slides. And so if you guys have any questions, just go ahead and ask me. I'll start with the company introduction, what we do, but. Really, it's more about kind of experience sharing. It's going to be just slides with some topics on them. So at any time, it's not like a really prepared talk. So any time, if you want, just let me know if you have any questions, and then maybe I can talk a bit more about my experience in that area. So let me first play. Oh, that's weird. Oh, okay, there we go. So let me first play one of our videos, introductory videos about what we do, and I'll go from there.
Hi, that's me, Joe. At least, that was me before Looped. A mere name on a paper badge. Disconnected, dejected, and unknown. I was nothing more than the badge around my neck. Scanned, swiped, and tapped to be remembered. Well, let's be totally honest. Forgotten. That old me didn't know it, but there had to be a better way.
That's when I met Looped. Looped is a smart device that makes corporate conferences that much more manageable with my busy schedule. Simply put, it's a two-way beacon that connects me with everyone else. You know what just happened there? We just exchanged contact information. It's that simple. Yep, just did it again.
Looped lets me passively exchange useful information. I no longer have to try and write everything down on the back of a business card while I lose an opportunity to meet someone new. Loop does that for me. And it creates a record of where I've been and who I've talked to. My paper badge never did that. Even though everything is automatic, Looped puts me in control of what and how much information is shared, from my contact details to demographics. But Looped doesn't just stop with making my life easier. With Looped, this guy can see exactly who I am, and if I'm worth his time.
Hey, Joe. Hey, we got a party later in the lobby.
I'll be there.
All right, great.
Looped lets me build a high-quality network with ease. When I get back to the office, the follow-up work with the important contacts is already done. It was done in real time, and I've got a record to show for it. Looped also benefits event organizers.
Watch this.
With Looped, social collisions and interactions are used to create a simple number called a VIA score. It gives event organizers eyes and ears all over the place, and the ability to be everywhere all at once. This instant information allows event organizers like her to optimize events in real time and analyze connections made between attendees, like myself, and sponsors, like my new buddy.
And say, oh, I want to send a survey out to everybody that was in this room for at least 30 minutes. And it's really powerful in that way, where there's a lot of contextual information behind that. Yeah, so basically a lot of insights. Oh, I can grab that. Yeah, thank you. So, yeah, we're a data-driven company, as all hardware companies are, because in the end of the day, it's how you present that information to your customer. And we're a little bit different from most wearable or most IoT companies in the fact that we're not a B2C company, we're a B2B company. And B2C definitely has its challenges, B2B also has its own challenges, and I'll get into that a lot more later on as well. Yeah, just some company stuff. We've won some awards. Recently won the IF design for this badge as well. So let's get into the hardware challenges part of it. All right. So, as I said before, I apologize beforehand for these slides. There's just topic slides. So our company introduction, we're founded and based in San Francisco. Right now we have around 13 employees. Expertise is in kind of hardware and software development. Won some awards. And I'll just get straight into basically some of the challenges that we faced so far. But I just want to clear up any questions. Does anybody have any other questions about what we do or how we do? Because I'm going to get pretty into detail about our challenges. No? All right, cool. All right, so I'll talk about Bluetooth especially today because our experience is a lot with Bluetooth. Can I ask how many people have worked with Bluetooth? Okay, so around 4 or 5, 6 people. All right, so Bluetooth itself, if you've ever worked with Bluetooth, regardless if you're using app or if you're actually doing the hardware aspect of it, or you're using, there's two different roles in it, there's central and there's peripheral. You'll know that there's a host of challenges that come with doing Bluetooth development. And so one of the things that we ran into, one of the challenges was always when it came to interfacing with the customer itself, because we actually use the phone to actually communicate with this as well. But, so a lot of people also start by saying this. A lot of people say, why don't you just use the phone to do this? Why can't software replace this? And that's a very, very common question we get. I wouldn't be surprised if you guys had this question as well. The very simple, well, there's a lot of answers to this question, but mobile apps themselves, you have to realize that they're kind of like small computers within your pocket, right? And as such, small computers, there's a lot of programs on it, there's a lot of things that are standby, there's a lot of things that are running, there's a lot of things trying to grab the core CPU's attention, trying to run their own processes. So it's a very big challenge for you to have something dedicated that's dedicated for wireless technology, that you're always trying to reach out, always trying to communicate with the outside world. So one of the challenges that we faced when we were trying to interface this thing with the phone regarding specifically iOS is iOS loves to go into power saving mode. Anything that it can kill, it will kill. And so this presented a lot of challenges for us, such as when we wanted the phone to start scanning for nearby beacons, nearby peripherals. For some reason, not documented whatsoever, wherever in the Apple documentation, the phone itself would start scanning slower. And then we only realized this through experience when we started scanning. We started counting as like how many advertisements am I getting in the phone, and then it starts slowing down, slowing down, slowing down. So it's a big challenge in working with these kind of third-party software platforms because you really don't have much control over the actual behavior of the device. This, however, we do, right? So when you have a dedicated device like this, you can just hand out to different people, and they come in. There's no buy-in at all. You don't have to tell them to connect to the Wi-Fi. You don't have to ensure that they have a good internet connection. You don't have to have them to create an account. All you have to do is say, "Hi, welcome to the event. Here you go," and then you're in, right? Yeah.
How do they transmit the data back to the server?
Yep. So the data that's transmitted back to the server, usually for these events, they have pre-registrations, or you can register on site as well. And so what we do is as they come in, they check in, and then this badge is tied to their identity automatically. Yep.
But once you collect the information, you gotta get it out of the device somehow into the server.
Yeah, I'll get into that very soon. So the other half of this is the aspect. So in Bluetooth, if you've ever worked with Bluetooth before, there's two roles in Bluetooth. There's the peripheral side of it, and there's the central side of it. And the central side is in charge of scanning the device. And so, actually, no, this is really good because I can get into the actual setup of how we do everything. So how do we track? So let's say everybody's wearing one of these badges, right? How do we track who's in the room right now? And what we do is we actually set up what are known as bridges or hubs within the room itself to act as a proximity sensor. And so this hub its job primarily is to translate Bluetooth information into information that it can send eventually to the cloud. And so this information is then, so back to your questions, like how is this information transmitted? It's transmitted through these hubs that we place in every single room or whichever sponsor that we want to place it in. Another issue with iOS are MAC addresses, and MAC addresses are not, MAC addresses, if you're familiar with wireless, yes?
Sorry, just a quick question.
Yeah.
At this point, are you using triangulation or are you just using?
We are not using triangulation, because triangulation itself requires you to be in a set space for you to never move the hubs or the bridges or whatever. Because the nature of our business is the fact that we're always doing events. So once you place the hubs down, you have to take them out again. So we don't have the ability, or we don't have the manpower, or it's not even scalable for us to go to every single event and try to triangulate every single thing. So it's more as in, okay, we're not really doing analytics in terms of like, oh, where are you in the room, but rather, you were actually in this room at this time. Yeah, so no, we don't do triangulation. We actually just pull in the data, the fact that you're actually near this specific location. For iOS, there's another challenge in the fact that iOS is full of challenges. They say they do background scanning, they say they do background connection, but it's kind of a hit or miss thing. It really, once you put your iPhone to sleep, it's more as in you're hoping to God that it can actually see anything that's around or connect to anything around. Another big issue with the power saving mode, as I said before, is another thing in Bluetooth is the fact that the information that's sent from this device is actually cut short, and it can't scan as frequently. And it also can't, because of a security issue, which is kind of really stupid at the same time, is that iOS does not allow for you to read the actual MAC addresses that are coming out of these badges. And so it's really hard for you then to identify exactly which badge this is. Somebody could be spoofing your IDs that you're sending out or things like that. And so it presents a hard problem in terms of iOS. It's like when you can't really know who is around you at that time. Next up is Android. I can cover Android as well. Android and iOS both have pros and cons when it comes to wireless technology. And for Android, it's really hard for us as Android developers as well, because Android has different hardware throughout its entire ecosystem. So you never know what chipset it's using for Bluetooth. You never know if it's actually Bluetooth itself was actually just developed for Android. There's one peripheral mode that was just recently introduced. And the Google official library for Bluetooth itself wasn't even officially introduced until a couple of years ago, I think. So as you can imagine, Android itself has so many challenges in terms of getting consistent performance. So if you guys are ever thinking about creating any type of wearable, any type of hardware device that depends on communicating with these mobile devices, that's something to keep in mind. It's getting better. It's definitely getting better, but it's important to be aware about these challenges. Yeah. iOS was the first one to start pushing it, and then so I don't know the exact dates, but iOS was definitely the first company, or Apple, first companies to start really pushing Bluetooth Low Energy. Android, there's a whole history behind Android, because Android's based off of Linux, and Linux has its own kind of Bluetooth driver, but Android itself, it had a licensing issue with the Linux version of, it's called BlueZ. So they basically completely rebuilt their Bluetooth libraries from the ground up in Android. So it was a little bit slower, but I think it was only in Bluetooth, I think it was only in Lollipop, I think it was 4 that they actually introduced Bluetooth Low Energy. So very slow, a lot slower than Apple, yeah.
Why did you guys take the decision to use Bluetooth, which is kind of more like consumer RF, you know, compared to like maybe a mesh solution, which would be probably more suited for your application?
So no, great question. So Bluetooth, there's a lot of, this actually gets into my 5th point, which is wireless really sucks. Yes, Bluetooth is one of the option out of a myriad of options. There's RFID, there's NFC, there's Bluetooth, there's Zigbee, there's, right now there's LoRa and there's Sigfox as well. The reason behind using Bluetooth was because of a combination of cost, power consumption, and probably compatibility with phones at that time. Even right now, Bluetooth is a better choice than all of these other choices. Because if you look at the other choices, you'll probably think of the second best option as to using RFID. RFID is not a really good choice. RFID is kind of like those stickers that you, like those highway stickers, and every time you pass by, you'll notice that there's these huge kind of readers that are responsible for reading those. So in electronics, there's difference between active devices and passive devices, and so passive devices don't consume any power when they're being operated. And active do consume power. But yeah, I mean, I'm getting a little bit too deep into this, but generally speaking, Bluetooth was, coming to the conclusion of using Bluetooth was a combination of all of these factors, and saying RFID is too expensive, the range isn't as high, wireless. So Zigbee wasn't compatible with phones. Zigbee is also not a low power. We do talk to the phone. We do talk to the phone. In the end, we do talk to the phone, not as a primary source, but yeah. But also Zigbee is not as low power as Bluetooth as well. So that's another factor in there. So yeah, wireless sucks. Wireless is something that it's wireless, right? So you can't, it's invisible, you can't really see it. You can't, it's hard to debug things that are in wireless, and you can't account for all of the different types of interference, all the different types of noise that will be in the area that you're going to be at that time. So I'm not sure if any of you have any experience in doing wireless development, but wireless itself is, so Bluetooth and wireless both operate on the same frequency at 2.4 gigahertz. Theoretically, they shouldn't interfere with each other, but it's not something that I've personally ever kind of proven to say, oh, wireless does not interfere with Bluetooth. It might not. But more of a problem is Bluetooth interferes with Bluetooth, right? And so when you have all of us kind of wearing all of these badges in a certain room, we have to see, you know, how much interference, how many people can we see at the same time? We have to benchmark all of these different things, and they're all kind of communicating one another. And wireless itself, it's difficult because we're not only counting on Bluetooth technology, we're also counting on Wi-Fi. And so Wi-Fi at the venues is the Wi-Fi at the venues good enough, right? Just because somebody is kind of walking past you and then blocking that wireless transmission, will that throw you off? So these are all different kinds of questions that you're going to have to ask when you're doing wireless development, because it's really a pain in the butt because there's just so many things that you can't account for until you actually get to that environment where the wireless wireless might be affected or it might not. Another problem with especially large-scale development is how do you test your hardware, right? And so if you think about kind of the size of events, there's 5,000 people, 10,000 people. How do you mimic that kind of surrounding? How do you mimic that kind of environment in order to make sure that all of your everything's going to go well at the actual event? How do you mimic 5,000 people walking around with these different badges on them? And how do you mimic that kind of signal? So hardware test environments are a huge issue. And it's something that's so crucial and critical to get correct for you to actually have success when you actually deploy to production. And this is one of the lessons that we learned very early on, because every single time it would work perfectly within the lab, but once we got to the environment, once we got to the expo, once we got to the actual place, this would go wrong, that would go wrong, and we would have to actually debug on the spot, which creates a lot of pressure, especially when we're in different time zones. Time zone issue is a huge issue as well, if you guys are considering time zones and having critical applications like this. But we were like up all night in Taiwan trying to debug these things that were going on in California, New Jersey, and all over the world. We had events in India and things like that. And so our developers pretty much had to stay up 24/7 just to assist these events. And it was a huge pain. So hardware test environments are hugely important in terms of if you're going to have to develop these things in products, make sure you have a way to mimic the actual production environment. So right now, we haven't gotten this perfect yet, but in order to actually mimic a lot of these badges walking around, we have to create these custom boards with like 20 different modules on them, and then being able to turn them off, on and on by ourselves. But it's a whole nother development process to make the testing environment. I'm not sure if a lot of you have done hardware development, but there's a concept of calling system, I think it's called system under test, system in test. But basically, it takes one engineer to actually develop the product. It takes two engineers for every one engineer to develop the entire testing environment that goes around it, right? So it's a whole other development process that goes in of itself. Say, okay, so now I have this. How do I actually develop all the other things that are necessary in order to gauge all of this, right? So yeah, design under test, DUT, SUT, or something like that. But yeah, anyways, how do you emulate that environment? How do you simulate that environment is a huge problem if you guys have ever done hardware development itself. Manufacturing. So we manufactured in Taiwan with a company called, I'm pretty sure you guys have heard of Quanta. But Quanta helped us manufacture. I think this is just general in terms of hardware development. Hardware development really sucks. Like, how many people here have developed a hardware product from zero to something before? Right. So not many, around 4. So I'm sure you can understand when you're doing something, especially if it's consumer facing. It's a huge problem to be able to get every single little point right. We've had so many problems just trying to get this to market. Like, even right now, like when people are wearing these things, they fall apart. They don't fall apart when we're working with them, right? But for some reason, people just come to us with these two halves of this badge. Like, one fell apart. It's like, how did you do that? They run out of batteries. How do you make sure that they're always the batteries are full? During the development process, different colors. It's a huge issue. So they're coin cell batteries, so very cheap batteries. Yeah, we replace them as well. And that's another thing, right? Our interns that are replacing these batteries, they're getting like burns after the at the end of the day, saying it's like you guys made this, you guys didn't make this very well. So it's yeah, their hands have blisters and stuff like that. And so these are all kinds of little things that you don't realize until the actual product is out, and then you realize, okay, now what do we do? And that's why hardware development is so hard, because you can't. It's not like a software process where you can keep on iterating on it. You have to say, okay, here it is, use it for a certain time, and then we'll come out with a version 2 of it. So We had multiple revisions of the same product. This is our second version, but we probably had around 5 or 6 different versions. I mean, there's a whole manufacturing process where they say you have to, at least with Quanta, I forget what the different stages are called, but they come out with the first phase where you prototype it, then you prototype it for a while, try to save it there in bugs, and then you come out with the second version and the third version. And just keep on iterating in short batches before you go into mass production. So we iterated quite a lot on this one. There was an issue where we underestimated the height of a single capacitor component on here, and then the whole thing wouldn't go together. So that was a huge pain in the ass as well. So hardware. I mean, if you understand hardware manufacturing, you'll understand that these are all the things that you're going to run into when you try to do hardware development, especially electronics. Big data. Okay, so that was a hardware aspect of it. The other aspect of it is big data, right? So let's say now you have your hardware product. It's doing great, right? Everything is up to speed. Looks beautiful. It's transmitting a lot of data. But then you think, okay, what do I do to handle all of this data? And big data is like a buzzword that's kind of being thrown around these days. But really, at the end of it is, how do you process millions of data points that are coming in a second, right? And so this is something we've also learned really hard, is because when we try to just use it as, what a standard startup company would do, and startup companies fail. Startup companies, the only problem with us is the fact that when we fail, it's in those 1 or 2 days that the event is actually going on. So it makes it even harder for us to say, oh, we failed. It's not like we could say, okay, well, we'll do better next time. But because at that point, the customer's already pissed off. And then it's like the entire event is gone because of you. But one of the issues that we had was there was so much data coming in, so much updating, so much inserting into our database. It started locking up our database. And that was really, really bad because, what was that? We've gone through multiple ones. Currently we use MySQL, and we're also using Postgres. We also use MongoDB as well. We scale on the cloud. I mean, we use cloud services for it. And even right now, right now we're to a point where we can insert documents. We're using MongoDB right now. We've migrated over to it. But the thing is, inserting data into a database is just one half of the problem, but calculating stuff from it is the other half of the problem. And so, okay, great. We solved one problem, right? We weren't getting any more database locks. And everything was inserting really, really well. But with millions of data points, now our queries are taking up to 10, 20, 30 seconds in order to execute. And to parse through all that data with our engine, it is taking up to 5 minutes in order to parse through all that data. And so now we're moving over to something that we're moving over to Apache Spark, which is more of a streaming service where you do streaming calculations as data is coming in on the fly. But this is all stuff that we didn't know before. We were thinking, oh, we could do this, right? In the end, we couldn't. So now we're hiring a data scientist in order to help us kind of scale this out and make it something that it can be a lot more robust. Constantly changing environment. I mentioned this before. The nature of our specific, and I'm sure if you ever want to do your own wearable, yes.
I have a question. What is data computing? Can you do it locally, or you compute in the cloud?
In the cloud, yeah. We do some compression. We do some filtering within the hubs and the things that are there, but most of the calculations. So if you can imagine, all of these raw data points are being sent, and our documents are looking like, who, what time, where, and then like millions of these kinds of data, and then we have to parse it out and saying, okay, who was at the session, who was at this exhibitor, stuff like that. It takes a lot of computational power to do that. But yeah, we do that computation in the cloud. Yeah. So one of our other challenges were the constantly changing environments, and I'm sure if you guys get into hardware development, you're going to understand this pain, because it's not only us, it's every hardware device that's out there. You make it into the lab, it works perfectly in the lab. Once you deploy it out into the field, it breaks down, right? So that's something that every hardware developer is going to run into. A lot of different factors, a lot of different issues. And yeah, that leads into my general hardware issues. The general hardware issues, which I mentioned before, is like they're falling apart. You know, a lot of things that you don't account for. And I think it's critical in the fact that when you guys want to start doing hardware development, it's not like software development again. Well, I mean, the software development is a little bit more lenient. You have to be experienced in order to deploy things to production. But with hardware development, if you get it wrong, you're screwed, basically, right? Because you've already manufactured it. You've already spent tens of thousands, hundreds of thousands, millions of dollars on product development, and when it actually out, you realize, oh, you know, I put the leads on backwards or something like that. Something stupid, something so stupid that it's going to definitely be overlooked. Then when you realize it, then you're like, oh, okay, now we're screwed.
Do you move the financial risk to your customer? Do you sell them the device, or you take the financial risk?
We have on-site operators. Yeah, we have on-site operators that actually go to the event to support, but once we hand it out, then it's theirs.
But I mean, the capital, like who pays for the devices, you or your customer?
The customer.
So once
Yeah, exactly. Yeah.
you don't take it back.
We do recycle them. We do recycle them. Yeah. And my last slide is basically another thing that you're going to have to deal with when developing these kind of things is, you know, are you going to do custom development, or are you going to use off-the-shelf components? And this is another aspect in terms of like, you know, this we made custom, right? And a lot of people were thinking like, why don't you just take something off the shelf? At that point, we were thinking, okay, maybe we should have done something. But at that point, no hardware device actually did something that we wanted. So that's why we had to make this entirely custom. But my one advice, if you were to do anything in terms of hardware, is try to use as many off-the-shelf components as you can, because that's going to save you a lot of money and a lot of hassle in the long run. Maybe not. Maybe their support's not going to be very good. Maybe you have the ability to do it yourself and you have the resources, which many don't, by the way. But yeah. So there's always the questions like, do we make this ourselves, or should we just use something that's already existing? So yeah, that's the end of my talk. If you have any questions, let me just leave my email on here, and then I'll open the floor to questions. Yeah.
How did you use the mix between internal employees and external design houses for mechanical, electrical, schematics, PCB?
Good question. Anything that wasn't core or anything that didn't take a really long time, we outsourced. So mechanical was outsourced, PCB was outsourced, schematics was outsourced. The only thing we did in terms of electronic design in-house was firmware design, because that's something that we had to keep on iterating on. Yeah.
It's always interesting to hear, you know, like where things went wrong.
Right.
Everybody talks about success.
Exactly.
You know, like another business, that's interesting to hear. Do you have any like maybe some anecdotes, you know, like where
Oh yeah.
you didn't expect at all?
So our first event. Yeah. Our first event was with Box. I'm not sure if you guys know Box in California, but they're basically the biggest competitor to Dropbox. More of a B2B company for cloud storage. And so one of our first issues, one of our first nightmares. Let me just say this: is like at the end of this event, our customers would basically flatly ignore us when they saw us in the hallway, and they just keep walking on. But yeah, this was horrible. Basically, we had kiosks that were set up, and then what attendees would do is they would take these badges. They would first check in with their information, then they would take these badges, and then they would scan them with the tablets. And the tablets themselves, they support Bluetooth Low Energy, right? And so then this goes back into the thing. It works perfectly in the lab, but when you actually get to the site, everything breaks down. And so you have, I think for Box, it was like 800 800 developers there. It was a developer conference. And it was around 800 developers all waiting in line to get the Loop badges. And so everything was going fine in the first part, right? But then, and usually these tablets, they take like, you know, at most like 1 or 2 seconds in order to sense this beacon. And then they tie that information. But it started getting slower and slower and slower, where we were waiting up to 5 minutes, up to 10 minutes in order just to register a single person. And then we had the whole backlog of people waiting there, and they're starting to get really pissed off, saying, it's like, why is it taking so long? And then our customers, the box organizers, they're getting pissed off too. And then we're like, oh, we don't know why. It worked perfectly back in the office, but it didn't work over here. And the reason for that is because the Bluetooth scanners on these tablets, they're not really industrial grade scanners, right? So that's why we moved to another solution. But yeah, these tablets, they can sense, you know, your Pebble, right? Or your Apple Watch or whatever that you're wearing at the time. When you have 100 different peripherals around, all kind of beaconing and all scanning at the same time, then it gets really complicated for the tablet in order to see, oh, which one is exactly near me at this time. Yeah, so that was one of our first challenges, and that really pissed them off. Pissed off our first customer. But yeah, I mean, you go through these kind of nightmares. Yeah.
I don't know how experienced you guys were as hardware developers when you started out, but is that these sort of problems, I guess what's the differential between, in your mind, a very experienced hardware developer versus maybe less experienced? Would a lot of these problems have been avoided?
No, I don't think so. Because I think what would have been better would be if we were to have a better testing environment. And it goes back to the thing where, how do you actually mimic the real event? And of course, sometimes you can't mimic it perfectly, but it wasn't in the event where we didn't have an experienced hardware developer, because that wasn't really a hardware problem. It was more of a, you know, we were using iPads at the time. It was an iPad problem that we didn't anticipate until there was literally, you know, thousands of badges all around. So, yeah.
That's kind of a twofold question. Just started working with Bluetooth like 2-3 weeks ago. But can you comment a bit about differences between pros and cons of classic Bluetooth versus LE?
Yeah, sure.
Also, what security options are available? Because I know the classic one you have the four-digit PIN numbers kind of thing, and Bluetooth LE pretty much has no security whatsoever, I guess.
That's changed. Yeah.
Yeah, and also because, like right now, I was communicating with a client just yesterday, saying that if you don't have security, anyone can just hack in and take over your device.
Yeah.
Like, but they don't find the value. They don't find that being a problem. They would rather have it be like a plug and play, like a Bluetooth headphones or a speaker or something like that. What are the options and how do you communicate that?
Yeah, both very big topics. I'll start with the first one. So Bluetooth Classic is what's known as Bluetooth 2, or Bluetooth Classic, yeah. It's made for high streaming data, for like music, not necessarily like HD movies or anything, but definitely music, and mouse or keyboards, stuff like that. That's the Bluetooth where you have to actually say, oh, I want to pair with this device, and then the other person has to say permissions, like, okay, I permit you to pair with me. Whereas Bluetooth Low Energy, it works on a completely different protocol, so they're not really compatible with one another. So Bluetooth 4 or Bluetooth Low Energy or Bluetooth Smart, it has a lot of different names. It is essentially something that is only made for low data transfer, and that's why it's low energy in the first place, right? Is because yes, you're getting advertisement packets every few milliseconds. And they're coming out very rapidly but because these advertisements are so small, it saves a lot of energy. And the only time they actually have to transfer anything is when a master Bluetooth device says, "Oh, I want to connect with you." So it keeps low energy. So it's kind of like the pros and cons. It really depends on what device you're developing and which avenue to go to in terms of Bluetooth. But yeah, they're completely incompatible with one another, and they serve completely different purposes. But that's about to change with Bluetooth 5 coming out, because Bluetooth 5 is going to be a lot faster, a lot further in range, and also low energy as well. So we're going to see a lot more intersection in between those two coming up soon. Yeah. Oh, sorry. So security. Security is also a big issue. So iBeacon itself is by nature is not very. So there's a few beacon protocols. There's iBeacon, there's Eddystone, there's you know a lot of other hosts, a lot of different protocols. iBeacon itself is not secure at all because you can mimic a beacon if you wanted to just by changing its local advertisement name. Where Eddystone is a little bit better because it kind of scrambles its advertisements every few seconds, and then as long as you know how they're scrambling it, you can communicate with it. Yeah, these are defined in the standards. So Eddystone is one of the standards. As for actual communication and encryption, yes, Bluetooth Low Energy was not very good at this in the beginning, but it's getting better. Like one of the devices that we're using right now has native hardware support for encryption. So I think it's like 128-bit encryption for every transfer, every piece of data that you send out. So it's getting better, yeah. But definitely encryption is one of the things. I think you can never really say you're fully secure with wireless technology. Even with wireless right now, it's hard to say you're fully secure because there's, you know, NFC is really good because there's no way that somebody can do a man-in-the-middle attack, right? You're placed right up against that thing, right? But with wireless technology, somebody might pose as the person that you're communicating with, and yeah. So I think it goes back to the inherent unsafeness of wireless itself.
The Bluetooth LE module that I had, you just scan it and just send messages to it right away. So like, what's preventing another person like next door doing the exact same thing?
There's a few different ways you could do it. You can set permissions. You can set encryption. You can set if you understand Bluetooth Low Energy, you'll understand that there's certain characteristics, certain services, and as long as nobody knows the commands to those actual services or characteristics, then they won't really know how to communicate with your device. And there's also encryption as well. Okay, so yes, they might say, oh, okay, I want to read all the data that you have in your thing, right? But then everything that's sent out is encrypted. So unless they know how to decrypt it, they won't be able to get it. Yeah.
What strategy do you guys choose in terms of the high-level protocols? Are you trying to follow standards, or are you making proprietary to live?
We are following protocols, a Bluetooth protocol, but we did make our own protocol on top of that protocol, which is a mesh communication. So we're enabling Bluetooth devices to communicate in a mesh network. Yeah.
But like even one layer higher where you exchange the personal information. I don't know, what do you actually collect? Like what do you actually send around?
Oh, right. So what we actually send around is just unique IDs that are tied back to our database. So we're not actually sending personal information. We're not sending your email as, all throughout the air. But we're actually sending out unique IDs, and those unique IDs tie back to personal identifiable information back in our database. I mean, it's not like a very unique protocol or anything like that, but it's.
So basically, right now you know who has been close to somebody at some point. Is that the information?
Yeah.
Like because in the video you had a lot of other.
Yeah. Don't pay attention to the video. This is bullshit. It's good at delivering the vision, but then a lot of people are like, what if I don't want to send my data out? What if I walk past this person? It's not bullshit, yeah, but it's taking that dream a little bit further than what is realistic and what is probable at this time and what should be, because it's a good vision, but you don't want to exchange information with somebody that you accidentally wave your hand to, right? So. Yeah.
Okay, last question of the night.
Yeah. Is there anybody that didn't ask a question then? Yeah. What was the biggest challenge? So there was the question how much time, or what was the biggest challenge? Or both? What was the biggest challenge in getting our first client? So we're a B2B company, right? And so we're working with companies like, these large companies with reputations to maintain. So when you go up to them and saying, hey, we're a 5-person startup, use our product, please. Right? There's a big challenge in that, in saying, you have to get what are known as advocates within And it's kind of like a force of personality thing, because you have to have really, really good salespeople in your team to get the other people to trust you. And it's a big challenge when you're working with these large companies, because you have to have, and during the sales process, you're always trying to identify who are the advocates for your product that understand your need and can convince everybody else within that company. So I think that's the biggest challenge. Yeah.
Okay, thanks guys. Let's give our speaker another round of applause.
Thank you.